This is Chapter B, Lecture 4, dealing with compound meters. Consider the song Pop Goes the Weasel, which is in 6/8 time. Listen to the first 8 measures of this music. On the basis of what we talked about in the last lecture, you might think that a meter signature of 6/8 time would mean that there are 6 beats per measure and the 8th note gets the beat. In fact, you might even have been taught that in school, but in a more sophisticated understanding of meter, that is not true. There are not 6 beats per measure in this music, and the beat is not an 8th note. The 6/8 is an example of compound meter, and compound meter obeys different rules. Instead, in 6/8 time, there are 2 beats per measure, and the beat value is a dotted quarter note. If you sing the song or if you listen to it, it will feel natural to tap your foot on the notes that are at the beginning of each measure and at the midpoint of each measure. So it would be something like, around and round the mulberry bush, the monkey chased the weasel, and so on. It would be quite ridiculous to try to conduct this in 6. We'd be breaking our arm doing that. It would be something like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, I would not like to have to do that as a conductor. And if you try to tap your foot to every single 8th note, I think you'll also find that that's pretty difficult to do. In this song, the beat is divided into 3 parts. So instead of counting it 1 and 2 and 1 and 2 and, we'd have to count it something like this: 1 and a 2 and a 1 and a 2 and a. That's what makes it a compound meter. It's compound in the sense that there's a 3 within a 2. Now, we could still write this in 2/4 time because it is a duple meter, but then we'd have to show a triplet on almost every beat. A triplet is an irregular division of the beat, and there's a short discussion of irregular divisions of the beat starting on page 29 of your book. Let's see a list of the most common compound meters. This is example B5 from your textbook. Okay, so the thing about compound meters is that the top number is going to be a 6, a 9, or a 12, rather than a 2, 3, or 4. The bottom number is still going to be a note duration, like a quarter note, an 8th note, a 16th note, maybe even a half note, but we're going to interpret the top and the bottom number a little bit differently. Notice that the top number of the meter signature doesn't correspond to how many beats there are in the measure. Instead, the top number corresponds to how many divisions there are in the measure. In a measure of 6/8, the 6 doesn't relate to the beats, 1, 2, but it does relate to the beat divisions, 1 and a 2 and a. In compound meters, we can still read the meter signature just like we did with simple meters. For 6/8, the statement, there are 6, that's the top number, 8th notes, that's the bottom number, in each measure is still true, and it will be true of all compound meters. But here's the catch with compound meters. As I indicated earlier, the top number of the time signature tells you the number of divisions per measure. You have to actually divide this number by 3 to get the number of beats per bar. The 6, 9, and 12 tell us respectively that there are 2 beats, 3 beats, or 4 beats per measure. 6 divisions, 9 divisions, or 12 divisions per measure. The lower number of the time signature tells you the duration of the division of the beat, or what is 1/3 of the beat. So for 9/8 here, the 9 8th notes, again, relates over here to the far right column. There are 9 8th notes in this measure, each of them being a division of the beat into thirds. In order to figure out what the beat is, we have to think of 3 of these 1/8 notes rolled together into a single duration, and that would be a dotted quarter note. In a compound meter, the beat value is always a dotted note, and it is always, or almost always, divided into 3 equal divisions. In the final lecture from Chapter B, I'll be talking about some additional matters that are taken up in the chapter that deal with rhythm and meter.